everybody. Today we'll do another video. And today we will continue on the dot product. And we'll do a section that is called direction, cosines. All right, so that is what this topic about. Well, part of it. So what they say in that when you measure direction counterclockwise, if I can get this working. Markers are not doing very well today. If I get something like this, right? So if I can get something like this, this is C, this is Y, this is X, right? And let's assume that you have an angle that, a vector that goes like this. A vector that goes like this, right? Then we call that vector V, right? Then we have an angle that goes like this. We call that angle beta. We have another angle going like this. We call that alpha. And we have another angle that goes, let me just move this vector symbol. We have another angle that goes like that. We call that gamma, right? Notice that all the angles are going counterclockwise, in the counterclockwise direction, right? Okay. So what they're saying is that if we have non-zero vectors, non-zero vector V, for example, then we can say that non-zero vector V or non-zero, you can actually say non-zero unit These markers are not helping me today. Unit unit vectors, right? Give me 1 second. Let me see if we can get these markers to work a little better. Unit vector I, J, and K. Let's assume that those are unit vectors, right? And they are non-zero vectors, right? Of course, they gotta be non-zero vectors. So, because if we don't have if we have a zero vector, then we have the other situation, right? So then we can say that V dot I equal what? It's equal to the magnitude of V, magnitude of I, cosine of some angle alpha. Which is, this also can be represented because, see, if you have a vector, if you have I, right, what that represent? Well, they represent the first point, right, which technically would be what? Will be 1, 0, 0, right? Because this represents I, J, and K. Okay, so now that we have an idea of what we're doing here, we can actually say that we can actually write this in a form of, well, we have already cosine of alpha. Cosine of alpha, right? Then we have cosine of beta. And then we have cosine of gamma, right? Okay, so now we can also say that cosine of alpha is equal to V1, because remember, this also represents V1 gamma, V2 gamma. Actually, you know what? Let me just write it down below this little bigger. So V1 comma, V2 comma, V3, right? So now we can say that this is going to be V1 over that magnitude and then we say that cosine of beta is equal to B2 over the magnitude of that vector, right? And then we say that cosine of gamma, this is not working so good. Cosine of gamma is equal to B3 over the magnitude of dot B, right? Okay, so we have the 3 now. Now we can write this in the form of, we can say that cosine of alpha, right? Cosine of alpha plus cosine of beta plus let me try the blue one. So let me use the blue one because it seems like this one is not working at all. We can say that cosine of alpha plus cosine of beta plus cosine of gamma is equal to B1 over the magnitude of B I, right? Plus B2 over the magnitude of B J plus B3 over the magnitude of B K, right? So now, with that being said, also they say that this follow that also follow the following unit vector, and because you say n because V under this magnitude is a unit vector, is a unit vector, we can actually say that cosine of alpha, cosine square alpha plus cosine square of beta plus cosine square of gamma is equal to 1, right? Okay, so let's do this. Let's do an example then. Okay, so I need this identity. I gotta write it down here. So cosine of alpha squared plus cosine of beta, cosine the square of alpha plus cosine the square of beta plus cosine square of gamma is equal to 1. Okay. So, let me just do an example here. The example says, find the direction angles. Finding direction angles. Right? That example, it says, and then find direction angles, right? So this is the example, but they say here, they say find directions. Find direction cosines first. Find directions cosine. Oops. Find direction cosines and angles and angles for v is equal to some type of vector. So 2i plus 3j plus 4k. Okay. Now, with this, like this, we can start doing the math, right? So, first, we need to find this magnitude, right? That would be a step 1. So, let me just do it right here. So, let me just do it in this little box. So, we do vector, the magnitude of this equal to the square root of what? We find the one for beta first. Let me just, actually, I think I need a little more room. Let me just do it here. Okay, so we find that cosine of alpha is going to be equal to d1 over the magnitude of b, right? But b is going to be, for this specific one, well, the magnitude is going to be the same. Right? So we do the coefficient of I, the coefficient of J, and coefficient of K. We take those and actually square them, right? That's 2 squared, 3 squared, that is 4 squared, which is equal to 4 squared is 4 squared plus 3 squared. Those two equal 20. right? So no. 3 squared is 9, and then we have 4, so that is 13, right? Plus, so do it. So 4 plus 9 plus 16, which is equal to the square root of 29, right? Okay, the same thing with cosine of beta, which is equal to b2 over b minus the b, which is equal to, but remember, in this case, I will just put the value, let me just do it right here. Let me just do it, that. I just put in the value. This 2 goes on the top of this 2, right? So we found that. Now, for this one, the magnitude is going to stay the same, right? All I need now, why? Because it is not going to change. So all I need now is to write the values like this. So in this case, cosine of beta is going to be equal to 3 over square root of 29, and cosine of gamma is going to be equal to 4 over the square root of 29, right? So we got those values now. Okay, so now that we have those values, probably I have to erase this. Okay, so we need to prove because the question is also asking as to also show that cosine square of alpha plus cosine square of beta plus cosine square of gamma is equal to 1. Right? They want us to show that, right? So now we found the cosines, right? Now we need to find the angles of every single one of them, right? So how we do that? For example, I want to do this, right? So what I do in this case, I take the inverse. So cosine of alpha is equal to 2 over the square root of 29, right? And then I get that angle alpha is equal to cosine inverse of 2 over 29 square root, right? And this is when I need the calculator, right? So when I do that, I take that. If I take, first what I like to do is take the simplify that number, right? Because it's easy to make a mistake. You just start plugging in numbers. If you don't forgot to put the square root in there, you will get the wrong answer. So take the square root of that, and that is equal to 5.3852. And that, of course, is equal over 2, right? Take the inverse cosine of that, right? So now, cosine inverse of that, this angle alpha is equal to that, which is going to be equal to 2 over 5.3852. So now I take the cosine inverse of that, So 2 over 5.3852, and it's equal to 68.2 degrees. So we found the first one. We do the second one, and we do beta now. Beta is going to be equal to the cosine inverse of, now I'm doing beta, I gotta use 3, right? When I was doing alpha, I was using 2. Now I find the angle with, or the beta angle will correspond to now J, right? So it's going to be equal to 3 over 5.3852, which is equal to what? So now I got 3 and I got 5.3852, right? So 3, so cosine inverse of 3, right, divided by 5.352 is equal to 56.2. So 56.2, I didn't know what they got. Now 56.1. Just they didn't round it up, right? So 56.1 degrees. Right? So now we have beta. We need to find gamma, right? So for gamma, the same thing, right? So it's going to be equal to cosine inverse of, now I am using 4, right? 4 over 5.3852, right? Which is equal to what? So then this is going to be equal to the cosine inverse of 4 over 5.3852, and it's equal to 42 degrees. 42 degrees. Right? So we found those angles, right? Now we need to show that this is actually equal to 1, right? So, and those values were, I think I erased them. Yeah, I erased them. But I know what they are. So, those values are, actually we have them right here. So, I got them, I got this one, I got that one, and I got this one, right? So what I can say is cosine squared of alpha plus cosine squared of beta, right? Plus cosine squared of gamma, right? Is equal to what? Equal to each value that we found, right? On this. So what we do is the following. So basically, now we gotta be careful here because I need to square every single one of them, right? So here we can actually do the following, right? So we can actually do the following. We can actually do that. Let me just erase this part. Actually, let me just erase this. So what I will do is find individually cosine square of alpha, right? So that is equal to what? Is equal to, or you can say that, yeah, so just let's do it this way. So we have a 2 over square root 29, right? To get rid of this squared, you need to square on both sides, right? So then I get the cosine of alpha is equal to 4 over 29, right? Right, so basically what they say, if I square this, if I substitute this value here, you know what, let's do it like that, right? So if I square this value, let's say that I substitute this value here, and I square it, I'm going to get this, right? And then cosine of alpha of beta, which is going to be the next one, 3 over the square root of 29. If I square this, if I substitute this back here and square it, I get the cosine square of alpha of beta, is equal to 9. If I square this, right? If I square the top, I get 9. If I square the bottom, I get rid of the radical sign, and I get what? I get simply 29. Same thing with this term right here. So cosine square of gamma is equal to 4 over let me do it back here. So cosine square of gamma is equal to 4 over the square root of 29, which is going to be equal to cosine square of gamma is going to be equal to, if I square that, right, that is going to be equal to 16 over what? 16 over 29, right? Now I put this together, right? Now let me just do a little box here. So let's say that cosine square of alpha plus cosine square of beta plus cosine square of gamma is equal to these values, right? This so, and then we get what? We get 4 over 29 plus 9 over 29 plus 16 over 29. Now, when we do that, we add this, we get 20 plus 9 is 29. We can say that cosine squared of alpha plus cosine squared of beta plus cosine square of gamma is equal to 29 over 29, which is equal to 1. Right? So we were able to show that cosine square of alpha plus cosine square of beta plus cosine square of gamma is equal to 1, right? So that's it for today. Please give me a like if you like this video. Just give me a like, share these videos, and subscribe. Thank you for watching.